Welcome dear student. Jai Swaminarayan. Today we will discuss a exercise of the chapter number 2 units and the measurement. So dear student, let us start with the first question given in the exercise. Chapter number 2 exercise question number 1A. The volume of a cube of side 1 centimeter is equal to blank meter cube. Dear student, here the side of the cube is given to you 1 centimeter. We need to calculate the volume of the cube which has a side 1 centimeter. So dear student, you know that the formula of the volume of the cube. What is the formula of the volume of the cube? Volume of the cube is equal to side cube, right? If the side of the cube is L, volume of the cube V is equal to L cube, right? So the volume of the cube V is equal to side multiplied by side multiplied by side. So we get the volume of the cube is 1 centimeter cube. But here we need to calculate the volume of the cube in a meter cube. So dear student, you know that 1 centimeter is equal to 10 raised to minus 2 meter. Or we can say that is a 0.01 meter. 1 meter is equal to 100 centimeter. Or we can say that 1 centimeter is equal to 10 raised to minus 2 meter, right? So instead of this 1 centimeter, we place a 10 raised to minus 2 meter multiply by 10 raised to minus 2 meter multiply by 10 raised to minus 2 meter. Or in a answer 1 centimeter cube, if you place 1 centimeter is equal to 10 raised to minus 2 meter raised to power 3. Here 10 raised to power, we get power is multiply. So we get the answer volume of the cube in a meter cube is 10 raised to minus 6 meter cube, right? Now question number 1B. The surface area of a solid cylinder of a radius 2 centimeter and a height 10 centimeter is equal to blank millimeter square, right? Here we need to find the surface area of the solid cylinder in a millimeter square, right? The radius of the cylinder is given to you 2 centimeter and height of the cylinder is a 10 centimeter, right? So radius of the solid cylinder R is equal to 2 centimeter. We need to convert this 2 centimeter into the millimeter. So 1 centimeter is equal to 10 millimeter, right? So the 2 centimeter is equal to 2 into 10 raised to 1. We can write or a 20 millimeter. We can also write a 20 millimeter. Similarly, height of the solid cylinder h is equal to 10 centimeter. Then we convert this centimeter into the meter. So 10 multiplied by 10, we get the 100 meter, right? So the radius and the height, we first convert centimeter into the millimeter and then put in the formula, right? Instead of this, we can find the surface area of the cylinder in the centimeter square and then we convert centimeter square into the millimeter square as we were discussed in a previous example. So here first the radius is converted into the millimeter. Radius we get 2 centimeter, that is a 2 into 10 raised to 1. It is equal to 20 millimeter and height 10 centimeter. So 10 into 10 raised to 1 mm, it is equal to 100 millimeter. So the total surface area of the cylinder A is equal to 2 pi r bracket r plus s, the formula of the total surface area of cylinder, right? So 2 value of pi we put 3.14 multiply by r, that is a 20 millimeter or 2 into 10 raised to 1 millimeter bracket r 20 millimeter plus 100 millimeter. If you calculate this, we get the answer 15072 millimeter square. Convert into the 10 raised to power. So 1.5 into 10 raised to 4 millimeter square. So here we need to convert the answer into the 10 raised to power, right? So 15072 is equal to 1.5072 approximately 1.5 into 10 raised to 4 millimeter square. Understand both the question number 1A and question number 1B. Now question number 1C. So let us see question number 1C. A vehicle moving with a speed of 18 km per hour covers a blank meter in a 1 second. So here, dear student, the speed of the vehicle is given to you 18 km per hour. How much distance is covered by the vehicle in a 1 second? So first of all, we need to convert this 18 km per hour into the meter per second. So speed of the vehicle V is equal to 18 km per hour. Dear student, you know that 1 kilometer is equal to how many meter? 1000 meter, and 1 hour is equal to 3600 second. So instead of this kilometer, put a 1000 meter, and instead of this hour, put a 3600 second, right? So how we convert 18 kilometer per hour into the meter per second? So V is equal to 18 multiplied by 1000 divided by 3600, right? So if you calculate this, we get the answer V is equal to 5 meter per second. So speed of the vehicle is 5 meter per second. What it means, right? It means that the vehicle travels a distance of 5 meter in a 1 second, right? So according to the formula of the distance, speed is equal to distance divided by time. So distance is equal to speed into time. So here we calculate the distance covered by the vehicle in a 1 second. So time t we take a 1 second. So v 5 meter per second and t 1 second, we get the answer 5 meter. So if the speed of the vehicle is 18 km per hour, the vehicle travels a distance 5 meter in a 1 second. Now question number 1D. The relative velocity of lead is a 11.3. Its density is blank gram per centimeter cube and or blank kilogram per meter cube. Here the relative velocity of lead is given to you, right? So what do you mean by the relative velocity? So relative velocity is defined as the ratio of the density of the substance divided by density of the water. So the relative velocity of lead is a density of lead divided by density of the water. So from that we need to calculate here density of lead in a gram per centimeter cube as well as in a kilogram per meter cube. So gram per centimeter cube is a CGS unit of density and kilogram per meter cube is the MKS unit of the density. So from this formula, if we take density of lead is equal to relative density multiplied by density of water. So dear student, here you have to remember that the density of water is a 1 gram per centimeter cube or 10 raised to 3 kilogram per meter cube, right? So you must have to remember this density of water. Density of water is a 1 gram per centimeter cube or 1000 kilogram per meter cube, right? So if you multiply relative density of lead 11.3 into 1 gram per centimeter cube, right, we get the density of lead 11.3 gram per centimeter cube. But if you multiply 11.3 into 10 raised to 3 kilogram per meter cube, because the density of water in kilogram per meter cube is a 10 raised to 3 kilogram per meter cube. So we get the answer 11.3 multiplied by 10 raised to 3 kilogram per meter cube. Or instead of this, we can calculate from this also, right? 11.3 gram per centimeter cube. How we convert this gram per centimeter cube into the kilogram per meter cube? 1 gram is equal to how many kilogram? 1 gram is equal to 10 raised to minus 3 kilogram. Divide by centimeter cube. We need to convert centimeter cube into the meter cube. So 1 centimeter is equal to 10 raised to minus 2 meter, and cube, that is a 10 raised to minus 6 meter cube. So if you calculate this, we get the answer 11.3 into 10 raised to 3 kilogram per meter cube. So density of lead is a 11.3 gram per centimeter cube, or 11.3 into 10 raised to 3 kilogram per meter cube, right? Understand all the four example of the question number 1, all the four question of the question number 1. Now question number 2. Question number 2a. Fill the blank by suitable conversion of the unit. 1 kilogram meter square second raised to minus 2 is equal to blank gram centimeter square second raised to minus. So here 1 kilogram meter square second raised to minus 2 is need to convert into the gram centimeter square second raised to minus 2. So kg, meter and second are the MKS unit, and from this MKS unit we need to convert into the CGS unit, gram and centimeter square. So dear student, 1 kilogram meter square second raised to minus 2. So 1 kilogram is equal to how many gram? So 1 kilogram is equal to 10 raised to 3 gram. So 1 into 10 raised to 3 gram. Now meter square. So 1 meter is equal to how many centimeter? So 1 meter is equal to 100 centimeter. That is a 10 raised to 2 centimeter square. And second raised to minus 2. That is the second raised to minus 2. So here 1 multiply by 10 raised to 3 into 10 raised to the power 2 square. We get the 10 raised to 4, right? Gram centimeter square second raised to minus 2. So if you calculate this power, we get a 10 raised to 3 multiplied by 10 raised to 4. We get a 10 raised to 7. So 1 kilogram meter square second raised to minus 2 is equal to 10 raised to 7 gram centimeter square second raised to minus 2. Understand? Now question number 2b. Fill in the blank by a suitable conversion of the unit. 1 meter is equal to blank light year, right? Dear student, here you know that 1 light year is equal to how many meter? 1 light year is equal to 9.46 into 10 raised to 15 meter. But here we need to convert 1 meter is equal to how many light year? So here 1 light year is equal to 9.46 into 10 raised to 15 meter. So 1 meter is equal to 1 divided by 9.46 into 10 raised to 15 light year. So if you calculate this, right, 1 meter is equal to 1.057 into 10 raised to minus 16 light year. Understand? Now question number 2c. Fill in the blank with the suitable conversion of the unit. 3 meter per second square is equal to how many kilometer per hour square, right? Meter per second square is the unit of acceleration, and we need to convert 3 meter per second square is equal to how many kilometer per hour square. So dear student, here you know that 1 kilometer is equal to 1000 meter, or we can say that the 1 kilometer is equal to 10 raised to 3 meter. So 1 meter is equal to 10 raised to minus 3 kilometer. So here we convert meter to kilometer, right? 1 meter is equal to 10 raised to minus 3 kilometer, and 1 second is equal to 1 divided by 3600 hour square, right? 1 hour is equal to 3600 second. So 1 second is equal to 1 divided by 3600 hour. So 3 meter per second square is equal to 3 multiplied by 1 meter is equal to 10 raised to minus 3 kilometer, divided by 1 second is equal to 1 divided by 3600 square hour square, because 1 hour is equal to 3600 second. So 1 second is equal to 1 divided by 3600 second. So if we take a 3600 square upward direction, 3 multiplied by 10 raised to minus 3 multiplied by 3600 square kilometer per hour square. So if you calculate this, we get the answer 38880 kilometer per hour square. So that is a 3.88 into 10 raised to 4 kilometer per hour square. So if you round up to the 2 decimal place, right, because in this question 3.0 meter square there are two significant figures, right? So we get the answer 3.9 into 10 raised to 4 kilometer per hour square. Now question number 2D. Fill in the blank by a suitable conversion of the unit. Here the G is equal to 6.67 into 10 raised to minus 11 Newton meter square per kg square. The value of the universal constant of the gravitation capital G is equal to 6.67 into 10 raised to minus 11 Newton meter square per kg square. Convert this into the CGS system, centimeter square, second raised to minus 2 and gram raised to minus 1. So here, dear student, capital G is given to you 6.67 into 10 raised to minus 11 Newton meter square per kg square. We write in upper direction kg raised to minus 2, right? So first we convert Newton into the kilogram meter per second square. So dear student, here 1 Newton is equal to 1 kilogram meter per second square. So unit of the force is a Newton. Force is equal to mass into acceleration. So 1 Newton is equal to 1 kilogram meter per second square. So if you place instead of Newton kilogram meter per second raised to minus 2. So we get 6.67 into 10 raised to minus 11 kilogram meter second raised to minus 2 meter square and kg raised to minus 2, right? So here we get kg into kg raised to minus 2. We get the kg raised to minus 1. Meter into meter square, we get the meter cube, and second raised to minus 2. So we get 6.67 into 10 raised to minus 11 meter cube, second raised to minus 2 and kg raised to minus 1, right? So now convert meter into centimeter and kg into gram. We get our answer. So we get 6.67 into 10 raised to minus 11. 1 meter is equal to 10 raised to 2 centimeter. So instead of meter cube, we place 10 raised to 2 centimeter raised to cube. Second raised to minus 2 as it is. Now kg, 1 kg is equal to 10 raised to 3 gram. So instead of kg, we place 10 raised to 3 gram raised to minus 1, right? So now 6.67 into 10 raised to minus 11 multiply by 10 raised to 2 cube, that is a 10 raised to 6 centimeter cube. Second raised to minus 2, 10 raised to 3 raised to power minus 1. We get the 10 raised to minus 3 gram inverse. So if we combine the power of 10, 10 raised to minus 11, 10 raised to plus 6 and 10 raised to minus 3. Minus 11 plus 6 minus 3, we get the 10 raised to minus 8. So our answer is capital G is equal to 6.67 into 10 raised to minus 8 centimeter cube, second raised to minus 2 and gram raised to minus 1. So dear student, understand question number 1 and question number 2 of the exercise, right? Remaining question of the exercise we will discuss in the next video.